Hello everyone, and thank you for attending today's webinar, How to Build Cloud-Native CDN and Bring Scalability to the Edge, sponsored by Varnish Software. Before we begin, I wanted to cover a few housekeeping items. On the left-hand side of your screen is a Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resources widget. Towards the end of today's presentation, we'll ask you for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to our moderator, Principal Analyst Jennifer Clark.
Thank you very much, Becky, and good morning or good afternoon, everyone. It's a gorgeous day here in Boston. I hope you are experiencing some similar sunshine. Welcome to today's webinar on how to build a cloud-native CDN and bring scalability to the edge. We have an august set of speakers to address this topic today. In addition to myself, we'll be hearing from Tushar Gohad, who is Principal Engineer and Software Architect at Intel, Guillaume Quintard, who is the Senior Engineer at Varnish Software, and Ram Venkataramani, who's the Director of Software Management for the Telco NFV Group at VMware. Before I turn the proceedings over to Tushar, I just wanted to spend a couple of minutes and set the stage for some of the key themes that we're going to be talking about today. Here's a nice eye chart to wake you up and begin with. The data is from a carrier survey we just completed last quarter. We asked carriers, when do you expect your company to commercially deploy NFV for the following use cases in a production environment? So their responses here show increased deployment across use cases, but some of the centralized VNFs that have led NFV early implementations, such as the Evolved Packet Core, IMS, are still leading the pack. However, right on the heels of these use cases, now we're seeing an increased focus on VNFs that impact today's conversation. So pushing virtualization to the edge of the network, along with the challenges that brings in terms of deployment and management, etc. So over 50% of our respondents will have vCDN production implementations by the end of next year. And the same goes for enterprise vCPE, almost 50% on the residential vCPE side. So we're pushing this virtualization to the edge, and that brings with it some challenges and issues. But first, what's the driver for building up the network edge with increased CDN, edge computing, vCPE? Mostly it's, doggone it, video traffic, as you see from this exhibit. Last year, video traffic, and we measure our traffic at Omdia on an annual basis, so this is our most recent data. But in 2019, the video traffic dominated with 76% of total global traffic. The numbers are certainly going higher this year, but within that traffic, video traffic from social networks accounted for the largest percentage, almost 50%. Ad-based video on demand accounted for 35%, and over-the-top video subscriptions for 20%. And then keep in mind that within this overall environment, overall traffic network traffic continues to double every 3 years. So just a quick word about gaming. Gaming's the fastest growing segment if you're looking at the growth rate from 2018 to 2019. But gaming is a small percentage of overall traffic. The nice thing about gaming is that it carries with it the highest revenue per gigabit, and it's a little bit pricing insensitive, so always something that carriers have their eye to. Then if we look specifically at the video traffic space, the traffic from over-the-top video grew at the greatest rate, which is saying something given the continued dominance of social video. So we see over-the-top video growing 42% year on year. And if you look, and we see this trend continuing as we look out to 2024. So how are the carriers supporting this continued growth of over-the-top video and overall video traffic? Well, with the robust growth in the video traffic comes an equally positive growth in the CDN market as our carriers work to strike a balance in terms of where they place content far enough down into the network to conserve network resources and improve customer experience, but not so far that they're causing an untoward operational and capital expense by the continued splitting of the CDN traffic into smaller and smaller locations that may not warrant an iteration on their own. So the carriers are looking for robust CD solutions that can react to these shifting sands of content, moving with agility as pockets or waves of demand move through the network. And a good example of this type of shifting demand is actually what we've seen in the recent pandemic. It expresses both the rising demand for video content and the need for service providers to react quickly to abrupt changes in demand, in traffic, and in the location of that traffic. So this exhibit expresses the change that we've seen from the COVID pandemic. And as you see from the exhibit, online video and TV subscription service usage has risen sharply during the pandemic, ahead of all other digital content and applications available to consumers. Over half of our respondents here have significantly increased or increased their usage of online video subscription services compared to the pre-pandemic habits. And we don't see them retracting any of those subscriptions as we look forward to 2021. So what we're seeing here is continued flood of traffic, very liquid movement of that traffic and of the demand generators for the traffic, and a need to support them in a flexible and cost-effective way that it at the same time improves customer experience. So with that, setting up that problem statement, let me turn it over to Tushar, who will take us through a little of what we're seeing at Intel that might be able to satisfy some of these issues. Tushar?
Thank you, Jennifer. For an introduction, I work at Intel as the principal architect for content delivery and edge storage. Many of you may not know this, but we have had a dedicated focus on CDNs for a few years now. We have been working in furthering the CDN and edge ecosystem through our involvement in network and storage architectures and investments in open source software. We actually have presence in CDN data plane as well as control plane software. Many of you may have seen like our involvement in the Nginx and traffic server communities, and also our openness program. Today, I'll give you a glimpse of a few challenges in this problem space from an infrastructure and orchestration point of view. And then I have a few of our friends from Varnish Software and VMware that will dive into the details of and important parts of the puzzle, which are software, data plane software, as well as the orchestration. So before we get into that main agenda, here's a recap of what content delivery networks are. Content delivery networks have a multi-tier architecture. Typically, at the top, what you see is a CDN origin, which typically resides in a data center or a public cloud environment, where content goes through the origination, transcoding, and in some cases packaging process so rating the content for delivery. And then it flows through through various tiers of CDN, typically called as the mid-tier and the edge tier. Traditionally, the edge tiers have been located at the POP or the central office locations, and with the advent of 5G, we do see that edge extending to the customer or the essentially the access edge, right, where the CDNs we do see those being pushed into far edge. And what does that what does that mean for the CDN infrastructure going forward is something that we will talk about in the next few slides. So let's pick out a few trends that Jennifer covered earlier, particularly the growth in over-the-top content from YouTube, Netflix to TikTok, the popularity of live streamed events, increased high-resolution content offerings in 4K or immersive, and pairing those with more and more connected homes and devices with better connectivity, going forward into the world of 5G. So less than a decade ago, if you look at the peak capacity across the world for CDNs, it used to be in the 1 terabit per second range. Today that same demand stands at about 150 times as much, at about 150 terabits per second. Also, if you look at from a latency standpoint, not too long ago, the glass-to-glass latency for live events used to be, in the 25 to 30 seconds range, and it was considered acceptable with mandatory broadcast delays. We are now targeting, leaving aside the broadcast delays, about under a second of glass-to-glass latency for live stream. So in general, the demand for capacity and the expectation on the latency front is only getting basically more and more worse from a current CDN scale perspective. Now, if you look at the data points on this slide, the most interesting trend that you'll notice is that video traffic typically outpaces the growth in the number of subscribers, which indicates that there are additional factors that are contributing to this growth. The consumer appetite for content is only growing. And as I mentioned earlier, the content is getting more personalized, localized, and immersive. So again, this is all putting pressure on the CDN infrastructure and pushing CDN providers to do more with less, service more bits to a growing fan out of users in a cost-constrained environment. So this has been driving the industry to focus more and more on agility and scale aspects of CDN infrastructure. Cache efficiency at the edge is the key to a successful CDN deployment and a more cost-efficient CDN deployment for both deployers and consumers, because it directly relates to the costs in CDN infrastructure, but also to the experience that, the quality of experience that a consumer gets. So in general, there is a need for a more CapEx-friendly model where available server resources, right, let's say CDN infrastructure resources, can be utilized and reutilized in a way that a CDN or more so an edge operator can leverage the same infrastructure for CDN and other edge services when and where there is demand. So, essentially what we're looking at is a unified platform strategy to address the challenges that are called out on this slide. A unified platform strategy that would simplify operation, would make hardware SKUs predictable, would make automation a far more efficient process. It would deliver cost efficiency, and going into the 5G world, like where we are talking about CDNs extending to the access tier, it would enable services to be deployed at far edge locations where which are usually resource constrained and typically unmanned. So automation becomes a lot more of a key requirement. Answers to a number of these scalability, resource, cost, and efficiency challenges can be found in the cloud deployment models. So we have Guillaume from Varnish and Ram from VMware that will dive deeper into the details of one such approach that we together have been working on. So before we go into the details of that solution, here let's recap requirements of CDN as a workload. So what you see here is are the typical content types that we encounter in the field, along with their compute, network, storage, memory, and security needs. The primary thing to note here is that not all content is equal. It's one thing to cache and serve static web content like HTML, JavaScript, or images, and it's another to deliver video. Live content, of course, comes with its own requirements. It needs a smaller, moderate capacity, but high endurance storage compared to VOD or video on demand, where the capacity is more of a need than let's say latency. So one more important aspect of this workload is also security requirements of this workload, where TLS processing at multi-100 gigabits per second speeds is fast becoming a requirement. So most of the web content has been delivered over the years as encrypted, and video is also catching up the same trend. So this makes platform requirements shift towards higher core count CPUs and NVMe Express based storage for video on demand, and potentially denser DRAM or memory based systems to deliver the live or the immersive content where latency is crucial. So given the heterogeneous mix of workload profiles that CDN is, capacity planning is always an interesting challenge. The purpose-built appliances that have been used with CDNs for years now are likely not the answer for the predicted growth of content that we expect to see across the networks of the world. Just to put things in perspective, we are expecting about 500% growth in the next 5 years. Right? So very likely the appliances is not an answer. So the challenge, the challenge or the answer, one of the answers to the challenges is basically consolidating CDN service delivery on a single, scalable, multi-purpose, but still a standard server platform. So towards a scalable standard server platform for a modern high-performance CDN, let's take a look at what Intel has in the toolbox. So our Xeon family of processors is well known. As we have been incumbent in this industry for a while. These offer optimal core counts and for processing, as well as instruction sets for optimizations for crypto, AI, and video processing. And we also have recently invested in custom CPU SKUs, which are optimized for CDN workloads, offering up to 20% higher throughput and lower latency, 20% lower latency for CDN-like workflows. Our network offerings, have 100 gigabit capability. So these NICs actually have been recently released with technologies like ADQ, which stands for Application Device Queues, which bring consistent latency and lower time to first byte which are important metrics for CDNs. They help improve those characteristics. So we have quite a bit of investment from top to bottom, from CPUs to NICs in the space. Some of the CDN providers are also using our TLS acceleration solutions like QAT, which stands for Quick Assist Technology, which is a discrete offload solution for crypto compression and hashing sort of usages. So we have seen the industry take advantage of all these solutions over the years, and we continue to innovate in this space. Next, talking about storage, which is a key requirement for CDNs, particularly as CDNs move towards multi-100 gig networking, NVMe storage is fast becoming a norm. So we have invested over last more than a decade in NVMe, moving the NVMe standard further, but also creating best-in-class NVMe Express SSDs. And our write-intensive TLC SSDs and read-intensive QLC SSDs are some of the most mature solutions on the market for CDNs, offering some of the best dollar per gigabyte price points for video on demand workloads. Now, I also want to put some emphasis on calling out the Optane technology, which is essentially a brand new media. It's not NAND. It offers very consistent latency, very low latency, so sub 10 microsecond latency for SSD form factor, and few hundred nanosecond latency for DRAM like form factor, DDR4 electrical form factor, which offers a great solution that is denser than DRAM at a significantly lower price point for the live linear workloads. Of course, the challenges in the CDN space cannot be solved by just hardware, right? It needs to be a smart mix of platform hardware, software, and resource managers. So in the next section, I'll hand over to Guillaume to talk about one of the most important pieces of the puzzle, which is software. Yeah, take it away, Guillaume.
Thank you, Tushar. Hi, everyone. My name is Guillaume Quintard. I'm solution engineer at Varnish Software. And first, we're going to start with why we could, what are the benefits of bringing virtualization to CDNs. And I'm going to gloss over the control and management plane, the performance implications, because VMware has ways of having access to accelerated functions. That I am going to instead focus on something that is sort of specific to CDN, which is the delivery, and it's in the name, content delivery network, and the fact that this delivery really depends almost solely on the user demand. That demand can be predictable, like a sport event. You know when it's going to start, you know how long it's going to last, and you can even estimate how many viewers you're going to have. Or it could be unpredictable. Say, breaking news, for example. You are going to have a thundering herd of you don't know how many users dropping on your platform trying to access the information. And in both cases, what's important is that it's going to fluctuate over time. You don't have real control over it. And it's not like you can put that on a backlog. You need to serve that information right away or basically lose your users. So the traditional approach for CDNs is to just prepare for the worst and just have more firepower than needed, which works fine. The problem is when you are not at peak capacity, you just have resources just doing nothing. And if you are able to recycle those resources when they're not in use, then you can have significant cost efficiency there. So it makes sense to have a way to shift resources around. And on the slide, you can see that, yeah, it's a way to decouple software from hardware, which is true, but it actually goes one step beyond. It's software from hardware units in the sense of a class of resources. CDNs are mainly going to consume three different kinds of resources in terms of hardware, and Tushar touched that already. Basically, you're going to have bandwidth. You need to push data out to the pipes. You are going to need a RAM for storage, and also for storage, but for different kind of content, like VOD, for example, you're going to need disk. And the interesting thing is that you are not going to need all those resources at the same time. Over the lifetime of your CDN, they are not going to grow at the same speed or even in the same direction. So being able to break an SKU in different parts, basically carving the resource pie the way you need it, is going to be a big advantage in that field. And I've started with reacting to the traffic, and in a very immediate manner. But there is something that is possibly at least as important. And reacting is more elasticity. Here we are going to talk about maybe plasticity or malleability. Something that is pretty important to understand with the CDN is that it's not just, okay, a swarm of machines, indistinguished, and they are going to do the job. Machines are actually placed into tiers that are placed into pools. Those pools are also grouped into point of presence, and those point of presence are located all across the territory, sometimes the globe. And those machines don't exist in a vacuum. There is a network of those machines. It's in the name again, content delivery network, and how those links are organized are greatly going to impact your jitter, your hit ratio, meaning your origin pressure, is going to dictate the latency, basically the glass to glass time. All in all, how you organize your network is going to dictate the quality of service to your users. And the worst thing here is that this topology doesn't have a solution that is predetermined, that is a silver bullet. It is going to depend on where your users are, what your content is, where your origins are. And all this is going to change day to day, week to week, month to month. Over the lifetime of your CDN, you are going to need to change that topology, make it evolve to follow the market, your users, and the content. So this is where, in my opinion, it makes a lot of sense to have a virtualized setup where you can basically rearrange and shape your infrastructure to fit your needs. So CDNs are great, virtualized CDNs are even greater. What do we run on them? And it's in my title. You know the answer. I'm going to talk about Varnish. So Varnish is a HTTP reverse proxy dedicated to caching. It can do a lot more stuff than that. It can do access control with geofencing, token validation. It can do monitoring, load balancing, content manipulation, such as video manifest editing, and it can do even more. But let's focus on the core business here, which is caching. And since we started with that goal in mind, this is something that Varnish is very, very good at. We have negligible time overhead. We are able to push hundreds of gigabits per second out of a single node. We can deliver, or we can store 100 terabytes of data in cache. We, of course, have native TLS termination. I mean, Varnish has been made to be extremely efficient and to push as much data and to store as much data as possible. And on top of that, there's everything that you would expect from a caching software. Of course, we can do cache replication, we can do request coalescing, deduplication, we can do prefetching. I mean, this is the Swiss Army knife of caching, and it does its job very well. And it does a few other things that are pretty nice in the context of a telco CDN. And here at telco CDNs, we are going to make a quick shortcut, which is it's going to be video CDN, which makes a lot of sense because if you are an ISP, you want to use your pipes to push the costly data. And as was said before, video is the largest volume of data. So if you can do that with your own infrastructure, you're going to do that because it's going to be way cheaper. And so Varnish is going to do a lot of things well, but let's focus on just three. The first one is going to be scaling. And you're probably wondering why I'm bringing that up, because the virtualized infrastructure is already supposed to do the scaling for us, which is true, but you also need your software to complement the underlying infrastructure. What I mean by that is that VMware or other solutions are going to be able to give you machines that are super small, like one CPU core, 64 megabytes of RAM, to behemoths with 200 G of network, 100 terabytes or more of storage. But if your software is only comfortable in a subset of that spectrum, then you are basically limiting yourself. And Varnish is able to operate at ease on that whole range, and is going to squeeze out any performance that it can from the machine that you give it. So here is going to be able to scale vertically, but it's also able to scale horizontally. In a virtualized environment, you are going to have machines popping up and down, left and right, basically. No pun intended. But Varnish is able to discover new backends, is able to discover new peers, and have information fluctuate and flow between all those. So this is the perfect combination with an infrastructure that is able to change as fast as what we're talking about. Also, and because we are talking about telco CDN, we want something that is going to perform extremely well with streaming, and that means all kind of videos and all the buzzwords that you've heard and all the acronyms that you've heard about online video, chunk encoding, OTT, VOD, live, ultra low latency, adaptive bitrate. All that is basically HTTP and comes baked in with Varnish. So it all comes for free, and with great performance because the underlying protocol has been majorly optimized. So it just flies. That being said, Varnish as its core is a HTTP engine, and we are able to interact with anything and everything that speaks HTTP. So any video origin that speaks HTTP, we are good. But that also means that we can expand outside of that scope and do web, we can do APIs, any kind of routing, logging, and measuring, monitoring. Those are stuff that, this is stuff that is available right away from Varnish without any change in the software. And because you have a virtualized environment and you can reuse the software, but on different machines at different sizes, and yeah, populate your infrastructure with the same software. And that is it for me. I am going to head over to Ram now. Ram, take it away.
Okay. Thank you. Thanks a lot, Guillaume. Hi. Good morning, good afternoon, good evening to you all. My name is Ram Venkatramani. I'm currently a Director of Solutions Management at Telco Edge Cloud Business Unit. So at VMware, we a couple of years ago, we made a conscious decision to make our technology be available and kind of be targeted at the telco use case specifically. And as part of that journey, we are today talking about how the VMware solutions can be leveraged for deploying a scalable and highly performant CDN solutions in the telco networks. So with that brief introduction, let me quickly go into how VMware looks at a typical telco topology for a CDN deployment. Now, if you really look at what all the various, from a telco topology standpoint, you have multiple regions. So you have the customer edge at the far right. Now, this could either be your handheld devices or television screens or things like that. And then you have, within the service provider, there are two major locations or geographic concentration of servers. One is your service provider core, which is the typical place where most of the telcos have majority of their capabilities deployed. And the other one, which is increasingly becoming the norm, is a mini data center or a micro data center that is distributed far into the network, closer to the end subscribers. So this is something that we call as service provider edge. Now, in addition to it, there is also a public cloud element, because many of the content that is kind of served could be actually sourced from the public cloud, so we cannot lose sight of that entity as well. But if you really look at it from a telco standpoint and what exactly goes into these specific installation areas, within the service provider core, that's where your majority of your control and management plane software is going to be deployed. So from a VMware standpoint, this is a place where we deploy our telco cloud infrastructure, which is our hypervisor across compute network and storage. And it encompasses not just your hypervisors, but it also includes the management components that goes along with it. And then sitting on top of this is our telco cloud operations solution. The telco cloud operations is providing a 360-degree view of the health of the entire network, all the way from the hardware to the software to the applications. And then it provides troubleshooting capabilities like RCA kind of functionality. And then we have telco cloud automation, which is the orchestration function that Tushar mentioned during his initial talk. So that provides the ability to orchestrate the very specific network functions from a lifecycle management standpoint. It's the one which decides where should I bring up a particular CDN cache based on the demand, for example. If you see a demand in a specific location increasing rapidly, then it could make a determination that, okay, hey, I need to instantiate another cache in this particular region, and it will dynamically instantiate it. That's the piece that is done by the telco cloud automation. Now, in top of this, you also have some of your centralized content delivery functions like your cloud DVR, your IPTV kind of services. All of they will also be typically deployed in a service provider core. When you move to the edge, the primary focus of the edge is being able to deliver the content, or the last mile delivery as the industry typically refers to it. So this is the place where you will see a lot of hardware acceleration being leveraged. And so the specific technologies that Tushar talked about during the section finds a major presence in this particular location. And then you have the caches themselves that Guillaume talked about also being instantiated in the service provider edge. So at a high level, this is the topology that we visualize as a virtual CDN gets deployed in the network. Now, from within, so if you just double click into the edge specifically, there are two possibilities for an edge deployment. One is the classic telco edge. Now, this is part of the telco macro network. And the other one is more on the enterprise edge. Like, for example, big apartment complexes or big shopping malls, they could potentially have an edge deployment within their premises to provide local acceleration to their end customers or end subscribers. So in this case, there could be a separation of the cache from streaming. So this way you could have the cache located directly on the enterprise premise itself. So that's what this slide is really talking about. But the beauty of this solution is that you have one consistent infrastructure that is delivering content across the entire delivery chain, not just within the telco macro network, but also within the enterprise edge sites. Now, again, depending upon what is the access that is being used, whether it is a mobile access or whether it is a wireline access, the appropriate access network functions could change. It could either be a VDAA, virtualized DAA function, for example, if it is a cable-based delivery model, or it could be a 5G UPF function if the access is a mobile access delivery model. So a single infrastructure, consistent infrastructure delivering content across multiple access types. So why, I mean, if you look at it from a telco network now, particularly when we talk about this distributed edge delivery model, one key question that rings in everybody's mind is, okay, how am I going to manage this? Because in the past, when we are primarily centralizing all the network functions in a telco network, the telcos probably had anywhere from 4 to 12 data centers that they would have to manage. So it was kind of a little bit manageable and controllable. But with the advent of 5G technologies and with the advent of low latency applications or use cases, there is a proliferation of micro data centers that are instantiated much closer to the subscriber. Now, if that becomes the norm, then the carriers are going to see very, very soon a requirement to manage thousands, if not tens of thousands of edge sites. So suddenly what was just a few handful of data centers has basically spawned into thousands or hundreds of thousands of data centers, and managing them, it's going to become a significant burden. So what VMware has done here is kind of architect the infrastructure in such a way that the manageability of this infrastructure becomes significantly seamless. So in order to enable this, what we have done is kind of separate the entire infrastructure into a data plane element and a control and management plane element. So the control and management plane element is centralized and deployed in the core data center. And what gets deployed in the edges are purely the data plane elements, or in other words, just the compute, network, and storage hypervisors. Those are the only three elements that gets deployed in the edges. By separating the management plane and control plane from the data plane, you achieve two things. One, you are reducing the manageability scope, and you're making it a lot more simpler. And the more important piece is you're dedicating more resources in the edge sites for the actual applications themselves. If you want to run the management plane also in the edge site, then that is going to consume resources, which will add to your overall capex and also to reduce the amount of useful resources to run any valuable applications. So this split model is the architecture that VMware has introduced in order to target this particular distributed deployment models. So given these technologies, I just want to quickly run through, okay, what does this all mean for the telcos or for any CDN provider, right? So the scalable virtualized CDN, it provides 5 major benefits. Number 1 is agility, providing an ability to dynamically scale up and scale down your CDN caches as the demand rises. And this is primarily possible because you are running on a virtualized stack. So if you see demand rising, then all you really need to do is to bring up another virtual machine or bring up another container, and boom, now you can start supporting the increased demand. And if you see the demand go down, you can do the same thing on the reverse. The second element is performance. Based on what Tushar was indicating in his slides, the entire stack is leveraging hardware accelerators as its core underpinning. So because of that capability, the solution is capable of delivering an extremely high throughput capacity. Like in the labs that Tushar was talking about, the three of us have been successful in validating the ability to run close to about 200 gigs of traffic through a single server. So this is something that we have validated in our labs. The third element is quality. Obviously, when we're talking about such high performance, it's also extremely important that we keep in mind the end user experience, particularly when it comes to video content. You cannot afford to have any jitter or pause or things like that. So it's very important that we manage the quality and maintain the quality of the element. The fourth key value proposition is the TCO aspect. Now, you're not deploying monolithic appliances over here. It's all based on standard x86 hardware, now which can be leveraged to run other applications. Like, for example, during off-peak hours, instead of running CDN caches on those servers, you can probably run the overnight analytical workloads. So things like that. So you can leverage the same hardware or the same stack to run other applications, thereby amortizing your hardware investment across multiple applications, and that reduces your overall TCO. And the last value proposition is from the manageability standpoint. By separating or isolating the control and management plane from the data plane, now you've significantly reduced your realm of management requirement, and that kind of makes it a lot more easier. So in a nutshell, from a telco standpoint, what do they get, right? Number one, they can now truly operationalize a wide CDN, extremely distributed CDN. So that's number one. Number two is scalability. Now they are able to now support millions of users from their network by an extremely distributed deployment model. The third one is faster time to market. Since it is all completely software based, if they want to launch a specific CDN service in a geography, then there is no requirement for major truck rolls, because most of the times you will already have some sort of edge deployment in that region. So all you really need to do is to instantiate the Varnish software on top of the VMware stack, and lo and behold, now you have a targeted service for that region. And since it is all remotely managed, and we can do a lot of troubleshooting activities also remotely, this leads to lesser truck rolls. So you don't need to necessarily send a technician to go and fix a problem, but we can do most of that stuff remotely as well. And then we talked about the TCO and convergence. So in a nutshell, what the Intel Varnish and VMware is presenting today is a tested, well-oiled virtualized CDN solution that we feel would be extremely valuable for the service provider community as well as the enterprise community at large. So with this, I turn it back to Jennifer for Q&A.
Thanks, Ram. So let me remind everyone to send in your questions. You have a Q&A window there. Just type it in, and we'll all be jumping on those to answer all of the questions that we have time for. It looks like we have about 10 minutes in front of us. So let me go with our first question. When or where do you see customers deploying the CDN cache in a telco network? Are you going to do it at the core, at the edge, or a bit of both? Ram, that sounds like it might be for you.
Yeah, so let me take that question. Thanks, Jennifer. So today, when we speak to most of our customers, what they are doing is they are actually going with this dual model. I mean, they have multi-layered cache pretty much. So most of the times they do have a centralized cache capability in their core data centers or regional data centers, which are typically huge in size, like it runs into multiple terabytes or in some cases even petabytes, right? But in order to increase the in order to reduce the latency of the content delivery, many of them are also looking at deploying additional caches at the edge of the network. And we are seeing this not just in the cable space, but also in the mobile space. So there is a customer that we have been talking to in recent times who is looking into this kind of a model to deploy edge caches to accelerate their in-house content over the mobile network.
Very interesting.
I can add a little bit something at the back of that. One thing that usually that question betrays is people fearing to make the wrong decision. You don't have to decide right away if you want to focus on the core or at the edge. This is something that you can build as you go. And for example, if you only have one location where you have a lot of users, we can definitely deploy an edge there. And if you realize that you have more and more edge needs, then you can deploy them there and later on focus on the core. Or you can go the other way, or you can go in parallel. So yeah, don't get scared by making the wrong decision. Here it's really put caching and put infrastructure where your audience is. And if you have too much edges, then consolidate on the core.
Thanks, Guillaume. Yeah, so it's an art, isn't it? Where to put the resources. Sometimes it's going to make sense very far into the network, sometimes not so much. Okay, so let's go to our next one. What is the effect of transport layer security, or TLS, on performance?
Tushar, do you want to take that one, or should I?
So, Guillaume, why don't you answer it? Given your perspective of the customer space, and then I'll add to it.
Awesome. So TLS is pretty interesting because this is something that we need anyway. A few years ago that was, okay, do I want to do HTTP only or also have HTTPS? Now it's the default choice. We want HTTPS everywhere. So it's not much of an overhead now. It's just baked in. And it's also pretty interesting because in terms of CPU cost, which is the only cost for TLS really, because there is no extra bandwidth cost. For CPU cost, it's only going to be at the connection time. Once your connection is established, if you can keep that connection open, then you're good to go. The kind of numbers that we're seeing is per CPU core, and it's going to depend on your CPU, of course, and the technology. And yeah, a lot of factors, but we see 150 new connections per core, which seems a bit low, but in the grand scheme of things, you usually don't have to connect over and over again because you are going to reuse your connections. And also, it adds a little bit in terms of delay because you have a few extra exchanges on top of the TCP handshake. But all in all, and it really depends on your traffic again, that overhead isn't that big. At the software level, and just to speak about Varnish, we are using OpenSSL almost directly, and OpenSSL is hardware accelerated where you can. So yeah, you really try to add as little as possible. That's it for me.
Very interesting, Guillaume. Thanks for that response. Okay, here is our next question. Does this CDN solution compete, coexist, or complement the MEC or the mobile edge computing solution or the edge computing solutions that carriers are currently deploying or considering deploying?
I'm going to say it complements. Really, that CDN solution is here a reference architecture to allow you to deploy your own. I mean, that's really the beauty of that presentation. I mean, Intel is the hardware. You run what you want on it. VMware is a virtualized platform. You run what you want on it. And Varnish has, since the beginning, taken a stance in creating tools and not policies. So basically, you use the software the way you want it. So, and I'm not saying that we're just dropping you in the field and with no direction. I'm saying that it's a reference architecture, and then you can do whatever you want, either use it directly or adapt it to your needs. And I'm going to say it complements, it can replace, it can be at the back of a CDN, it can be completely integrated at the MEC level. It's really completely open. It is going to depend on the rest of your infrastructure. But yeah, with a virtualized solution, things can flow. As I said, you can rearrange the network traffic so that you go from one item to the other or the other way around. So it's definitely open here.
Very interesting. Thanks for that. And this is a related question. With satellite broadband IP networks and challenges with latency, keeping it, I assume what he's saying here is under 600 milliseconds, how would edge CDNs play out with traffic at uplink gateways and on the user end, such as VSAT technology? It's an interesting angle, isn't it? I've stunned you all. Who do you think?
Yeah, this is interesting. Sorry, go ahead, Gabe.
Well, no, I was going to say I'm not too knowledgeable on that one. I'm just going to draw the parallel in certain parts of the globe where, yeah, you have low latency without even going with satellite technology. But yeah, they are just there are cases, regions that have low connectivity, or yeah, on boats, for example, or in planes where you have very limited connectivity. And this is where you're going to see micro nodes, basically, to really try to isolate and reduce the external traffic. So it works. It definitely works. And yeah, it really comes down to micro nodes, and really there is, as said Jennifer, an art in setting up your topology, your structure to optimize that. It's not really about the software anymore. It's really about, yeah, how you deploy it and where you deploy it. I think.
Thanks, Guillaume. That was that makes sense, and it's a tough one because it's some of these connectivity families we don't usually look at on some of these early stages. But we have time for just one more comment. Tushar, I think you wanted to add something to the transport layer security, or TLS, conversation that we were having. And I think I moved ahead before you had a chance to add in your perspective. So So what did you want to add about that?
Yeah, I'll keep it real quick. You only have a few seconds left here. So TLS, we actually between Intel and Varnish, we actually have been doing a lot of joint work in optimizing that data path. Varnish, of course, has an excellent in-process TLS implementation that delivers the best-in-class TLS performance. But we are actually trying to improve it by reducing some of the memory copies that we have, which reduce the memory bandwidth need and also some core count need, compute need, basically. And we are jointly exploring approaches to hardware offload, be it inline TLS, or offloading at least the portion from user space to kernel with KTLS like approaches. So those are I would say it's one of the most important optimization problems in the CDN space today, which is TLS path. Again, the quick is still, quick stays interesting, but we do see kind of TLS, being here, right, and us working together with Varnish on optimizing that going forward. So I'll just leave with one last comment, which is on our upcoming processor family called Ice Lake. Intel actually has a new version of the instruction set, the crypto instruction set, which brings in the promise of improved AES GCM performance, which will also help improve the TLS improvement, performance or the CPU footprint. So we're looking forward to that. Yeah. Thank you.
Thanks, Tushar. And with that, everyone, I'm going to close out today's webinar. You'll see a link to a survey in front of you now. Please do let us know how we're doing here. We'll appreciate the feedback. And I'd like to very much thank our speakers this morning, Tushar, Guillaume, and Ram. A great webinar, gentlemen. I learned something. I think everyone did. So thank you all very much. And with that, I am closing out today's webinar.